Hey, welcome back on Cafe Dev. Today's will be the third streaming of July around IoT, and today's topic is how you can automate IoT devices IoT app. Let's get started. Welcome back on Cafe Dev. As you know, I'm streaming live every Thursday on this month on July to give you the basics of how to create IoT solutions in Azure. So we already had two other streamings. The first one was around IoT Hub and IoT Edge. The second one last week was about IoT way create IoT solution based off SaaS solution. So basically, you can pretty much create whole IoT solution without having to code anything. So if you're interested in this, please check out the last episode on YouTube. And for today's episode, I wanted to give you a bit of information about how to automate IoT devices management, because it's one of the key reasons to actually cloud solutions within IoT is to give you more power and tools to actually automate huge IoT devices and to secure. So that's the topic for today's streaming. So I will switch to and for today, unfortunately, I don't have any co-hosts, but I should have a co-host for next week episode. So you can find, you can follow along while I'm doing this tutorial. And if you're watching the replay, don't worry, you can access all this tutorial live on Microsoft Learn. If you want to access mostly Microsoft Learn modules, you can also JulyOT where, as I said, yeah, the introduction to Azure IoT, Azure IoT Edge, Azure IoT Central, and today's episode around the automate IoT devices. You can also IoT Hub. So if you want to get access to this collection, just have to go to aka.ms/JulyOT/learn, and I will copy paste around this link into the YouTube video description. It's all and again, if you have any questions, if you're watching this live, do not hesitate to Twitter or to write a small message in the chat window. And if you have question while watching this replay, so if not 5 seconds, you can still come on the YouTube video and I will answer okay. So let's get started and actually start the module around automate IoT devices Azure IoT. So today we will do a couple of different things. Some of the things, if you watch the episodes, we already done this kind of like creating an Azure IoT hub with the Azure CLI, creating IoT devices, We've done this with the Azure portal and with the CLI as well. We've also created simulators, IoT simulators based out of a C# program. We will do this as well today, but we will make it a little bit more complex and trying to mimic how we can implement firmware update IoT guys. And then we will see at the end of the module how we can simply test firmware updates from the Azure portal. Basically, create a new fake, create a new firmware, and push it to one specific guys. And how you can use the tools Azure IoT Hub to actually scale this deployment from one device to 1,000. Okay. So to follow along this module, you will basically need to know a few things about Azure IoT, specifically Azure IoT Hub. If you don't know anything about it, I highly encourage you to check out my first video on FLM. And if you already know Azure IoT Hub, go a bit deeper into what is Azure IoT Hub and how you can use it, leverage it projects. We will do a bit of things in the Azure CLI, but if you don't know it, that's okay. Very basic thing there. And we do some C sharp, but again, what we do is C sharp. You can do it in other lengths, and including C, because most of the devices, like small IoT devices, are actually written in C. These kind of things are really do it Azure C. So with that in mind, let's go to the introduction and actually talk a little bit more about the scenario and why you need this kind of thing. So with that in mind, maybe we can start with a drawing like every time. So when you're doing IoT solution, one of the things that is quite complex is that actually you can have a lot of different devices that may or may not be connected. We already saw that in a right. So some of them are connected by gateway device. Uh, so basically, they get their internet connection from way. The other one are kind of directly connected to nets, but sometimes only. So every 5 minutes, within an hour, or that kind of things. So it could be complicated to actually manage these differences activity. So one of the issues we need to address when we need to do the device management is activity. A lot of differences issue. So one of the issues we need to address. The other issue detection of so basically when you have a lot of 10 different type of devices, maybe devices A, A and A, but so when you're, for example, try to obviously be able to target only the A type of device or the B and but even more, maybe the A device actually connected or interacting with sensor or the device hardware industrial device X, and the other one is an older generation. So actually, maybe you have the exact same IoT component, but these components third, okay, and you may need to manage a older generation number of devices that are actually same IoT component, but these components third. I see this for but more simply, you can have this device on I see this for tools. customer one, or simply you can have this device. I'm very bad at drawings today. Custom two, and this one is choose customer one. So doing this, you will need, if you manage very bad at drawings today, single IoT solution for addressing different to be able to target specific devices customers. And maybe customer one is a very specific type of customer that don't need latest updates, but be able to target only customers. Very battle test. So when you're actually deploying a firmware, you may need to actually once and not at all. And like first deployment, very battle test start by when you're actually deploying and customer and then once and not sorry three and customer two and second time deployment. So that's the kind of issues we need to manage when we are deploying a large scale solution Azure IoT without targeting so we will see how to manage all of these things with module when we are deploying a large scale solution Azure IoT. So the first thing we need to set up is basically again, and each time you will do a Microsoft Learn module around IoT Hub, you will need to actually create a new IoT Hub, create some devices. So that's something we already done in the module. So I will go ahead and we need to set up is basically again, and I will activate new sandbox. IoT Hub, you will need to actually create a new IoT Hub, create some devices. So that's something we already done in the module. So I will go ahead and we need to set up is basically again, and I will activate. So when I've activated the Microsoft Sandbox permissions, the Microsoft Learn will actually create a sandbox so I can create Azure IoT. If it's the first time you see one of my episodes and you don't know what is Microsoft Learn, it's basically an online website where you have a ton of different, I think it's thousands of different learning modules. And when you have one learning, if it's the first time you with a sandbox, you can actually have access to Azure without having to pay anything or without having to use your existing Azure. So it's great for running. And when it's done with a sandbox, when you're done with the sandbox in 1 or 2 hours, then everything get erased. So you have to think about, oh, I created this and this resource during the learn module, and I need to move them, delete them, so I don't. When you're done with the sandbox, voice it for everything is done. And everything and when you have access to the Azure portal, we will see later on in this module, and to an Azure Cloud Shell things. So what I'm connecting to the terminal, one of the first steps you will need to do, and it's only if you're using this Azure IoT CI for the first time, or if you're using the Azure Sandbox, because each time you create a new sandbox, you get new environment entry. So you need only if you have a bunch of these things again and again, but that's okay. So the first thing we need to do is to actually install an extension, the Azure CLI, so we get access to all the IoT related Azure CLI. Please note if you're watching this episode live that this command is actually not correct. To actually install the extension, type az add please note if you're watching this dash dash name live and simply Azure is actually IoT. That's okay. There is a mistake. I've fixed it, and it should be updated hours and SQL website, so we do not have an issue. And why I'm installing the Azure CLI? I've fixed it, wait, you need to know that there is two versions of the Azure IoT CLI. So the first one is Azure, the command extension name Azure IoT Next. It's a previous version. If you want to do it right now, I highly encourage you to just the extension with the name Azure-IoT. And you need to know that there not belong it's together very well, so you cannot install both extension. Actually you can install both extension at the same time, but you will have weird configuration. So if you already have installed previous extension, uninstall it before both extension. So now I've added my extension. I will create yep, and again for this we need two different things like the hub name. Remember, the hub name is public, part of the Azure IoT Hub URI, so everybody can discover it. So yep, and again for this we need two different things like the hub name. Remember, a resource group, part of the else one URI, so everybody can discover it. So it will take a few seconds to create, and then we will go ahead and create an IoT Hub device identity. So as I said during my introduction, what we will do today is create a device simulator, and then we will connect this device simulator. Yep. And the second step, we will create several device identities. Link several devices. That's for the next step. So for now, I'm creating just one device, IoT Hub, and I will second step we will create several device identities. Oh, several devices. That's for the next step. So for now, I'm creating just one device, IoT Hub, and I will oh, several devices. That's for the next step. So for now, I'm creating just one device, IoT Hub, and I will oh, several devices. That's for the next step. So for now, I'm creating just one device, IoT Hub, and I will oh, several devices. That's 1, 2, 3. One. Okay. So I think I fixed the audio issue. Please let me know in the comments of the video if you have if the audio is doing good again. Okay, I will check it in a minute. And sorry for this small issue at the. What I will do while this is running is oh yes, it's running. So now I will my IoT device, and I will need again hub name 3 and a device name. Okay, thanks Rob for confirming that the audio seems. So let's create this device, and now I will just need to display the actual connection string, because I will need it in the next steps. Just use show connection, and I should have my connection string appeared there. Okay. So I will leave this there, and I think we can go ahead and do a little knowledge check. So which Azure IoT extension for Azure CLI command you should use to create a new IoT app, and if you paid attention, actually the correct answer one of these four and is AZ IoT Hub. So all the Azure commands are like that. It's like a hierarchy of commands. So AZ is the Azure command, IoT is a group of commands, Hub is a subgroup for this specific feature within IoT, and Create is the actual. And the next question is to create a new device ID in IoT Hub using Azure CLI, you will need a few different things. So actually it's quite easy to answer this, because you still have the answer appear right on the screen, which is to create a device identity, we need a hub name and a device ID. So the correct answer is IoT Hub instance name and a new device ID. And if I didn't make any mistakes, let's see, I should have all greens. Yeah. So next step is to get more information about how to do firmware update Azure IoT Hub. So there is a lot of different things there, but there is things that are very interesting in this text. I will not read aloud that text. It would be weird, I think, for you. And you can, if you want to learn all these things, you can definitely check out the Learn module. But I will highlight a few interesting things where talk about updating the device file. So one of the first thing is actually most of the IoT devices firmwares are not updated like the smartphone or apps on your. What we do most of the time is when we push a new firmware, we actually push everything, including OS and all and apps. Okay, and even more, some IoT devices doesn't have an OS. They are directly running code without an OS device itself. So actually, when we push a device firmware update, we are pushing everything at the same time. All the apps. Most of the time, there is one app, and also it can varies depending on the IoT devices, but most of the small lightweight devices are acting that way. And for this, the fact is you need to be very specific to the hardware itself to actually be able to. So Benjamin is talking to me about the stream, but it seems fixed. If you have any other issue, please let me know. Fixed. It should be fixed now. So if you have any other issue with the audio, please let me know. So yeah. So the fact is, even if you have created only one application, but you're deploying this to several type of devices, fact is you will need to firmwares. So there is a huge topic there around DevOps for IoT and how you can simplify all your DevOps pipeline to actually all the firmware. How you build an actual firmware for your devices. All these topics is out of scope for today's streams, but if it's something that is interesting, a topic of interest for you, please let me know in the chat or in the comments, and we'll see if I can do some videos around that specific. So for today, we will just assume that you know how to create a firmware, and you actually want to have a binary file hosted somewhere in Azure, and we will see how we can take this firmware and push it to the other part that is not the specific topic of this, how you can actually ask the device itself to install the new firmware. So as you will see in this device simulator, we'll develop, actually we create within the module, is we get the device update order and we execute that command, and basically that's it. We are not actually, we will not, I don't know, install a new version of and on. But it's very important to be able to do firmware updates without having to actually touch the device. It's much more important today's security in mind, because some of the security you will need actually push a firmware update very quickly. Huge set of devices. So if we talk about OTA, firmware update, OTA means over the air. We will need to actually have different things. We need to have a unique identifier for any firmware. As I said before, we will need binary file format for each type of devices. We will need to push and locally store on the device a new firmware while it's flashed. And they may be different type of operation before or after flashing a new device, like for example rebooting. Again, this is out of scope, but you need to ensure that you know how to do it. So now we will jump into how to do it with Azure IoT and how Azure IoT Hub can actually help you achieve this goal. And we do this through a feature called the automatic device management. So the automatic device management is based on another feature of Azure IoT Hub that you may want to use other scenarios, just applying firmware updates. And this other feature is called the device twin. So I will step back a bit for something like 5 minutes to just dig a little bit about what is a device twin, what you can actually with a device. So there is a great documentation page there about how to understand and use device twins is in IoT Hub. And I think one of the things that perfectly recap what is a device twin is so basically a device twin is an object, JSON object that is an image of your IoT devices that is stored on the cloud, and when there is any changes happening on this document twin, both devices app and backend app could provide and take action. So we have several things. This device app. Actually, we have a third one, which is not listed here. Update this drawing live with you. So actually, so the device we need is composed of different things. One of the things that is not displayed there is the device device identity. Device. It's a bunch of properties that are read-only and contain several things that could be interesting. We'll see them in a. Then we have tags. So tags is like metadata. You can use these tags to because the device twin is stored device database. IoT Hub, you can store a bunch of different there, so you don't have to actually have another device database somewhere in your system to store things like location of the device itself, or model, or customer ID, these kind of things. So you can store small properties directly in the device with tags. And then you have the properties. The properties tags are only meant to be basically by the backend. Okay, so when you want, for example, to push an update to only one type of customer, you can actually use this customer ID property to filter or query all your devices. Properties are meant to use by both the device and backend. And there is within the properties there is two types of properties. There is a desired properties and supported properties. And why we are creating two kind of properties? Because it's basically desired properties is mostly properties that are desired from the backend for the device and reported way for the backend to know what is the actual state of the device. Do not forget, when you think about it, and why we need to maybe do this a little more complex thing is because actually the device may not be able to connect to IoT Hub all the day. As we said before, we can have connectivity issues or we can have very low connectivities. So at the time you want to push a new firmware update, maybe a group of devices only connected, only notified of firmware update in a day or 5 days. So you actually need to be able to track any updates when you want to change something on the device. That change may happen. That's why we have these two blocks, the desired block and the reported block. So in the backend, you can compare if desired properties are the same of the reported properties, then it means that your device is up to date. And when you have difference between the desired and the reported state, then you know that your device is still not. Okay. So that was a quick explanation of what is a device twin and how you can many other things. And we will actually use all these different things for managing the firmware update. So let's back to the Microsoft Learn modules and see how it's done within the. So basically what we do during the module is we, through the Azure portal, we will create a new order, new query to the system to update a specific set IoT devices. Then the automatic device management feature of Azure IoT Hub will actually go ahead and change the desired property of all the device twins of all the devices. So even if you have millions of devices where you want to push them firmware updates, you will actually be able to do it in one single operation without having you or any code call 1 million times the Azure IoT Hub to actually do it. Then, sometimes in the future, your device application will receive a new desired property. And then you will need to create a specific firmware update handler that will actually start the update process, firmware update process by downloading the image, trying the image onto the device, and most of the time we boot. And then when the device is boot, you will need to report the status, basically change the reported property of the device twin to actually say, yes, I've updated my current version is not 1.0, is 1.1. And then the firmware automatic device management system can actually show you the number of devices that. Okay, so let's stop talking. We have half an hour and we will start actually writing something. And do not hesitate. I'm watching from time to time the questions, and I think started on whatever we are watching. I've already copy paste all the code onto my system in Visual Studio Code, so I have already everything. But if you want to follow along, it's quite simple because there is only one file code. And actually, if you don't know, you can do all of these things directly Azure portal, like the Azure Cloud Shell. Sorry. So as you can see, I'm creating a new .NET project directly within the Azure Cloud Shell. Even if you don't have any C# toolings, no C# SDK, no Visual Studio Code, don't worry, you can do everything directly within the Azure portal. So the project is quite simple. I will not do all of them in the console because again, I've already done it on my local development machine. But basically, you only need the Azure Devices client libraries and a JSON parsing library. And then you have some code, but we will see actually that code. So next, we will start the simulator, and for this, I will need connection string, which is there, and I will actually start the code within the code. I will just update my launch arguments, because the way this code is done actually, and that's quite interesting, is you can actually execute this program and just passing an argument with the connection string. So don't have to modify any code actually. And one of the things I will do, ensure, is I have a breakpoint somewhere, and we will see we'll actually run the program and see how it's done. Yeah, the main. Go on that one and type F5, see incorrectly, and it seems so. Yeah. So I've launched the execution of my simulator, and we will step within the execution so you can understand how simulation code is working. So to communicate from my device, the IoT Hub, we need to install device client. The only thing we got from arguments of the CLI program, and then I only have there only one on device. Then I will initialize the device. So what we do when we initialize the device, actually the device client is already boot when you get it. The only thing you need to do actually update the device. So if we go back if we go back on the diagram there, the fact is each time we boot the device, actually update the device twin current firmware version. Okay, that's one of the things we do most of the time. Each time the device is booting, you update the device twin properties, sure that your device twin boot is correct. So that's what we do there. So we can jump on this code there to understand how you can actually update the device twin from your okay. And for this, we use an object called the twin collection with a more or less a dictionary of string values. And as you can see, we have a bunch of different values we want to update on, like the current firmware version, pending firmware version, the update status, and the last firmware update time. We have two times, the start time and the end time, because it could be interesting to understand that maybe a device took, I don't know, 10 minutes to actually download the firmware, flash it, and reboot it, and maybe during that time, the device didn't send any data back to the cloud or properly function. That's kind of metrics you may want to, but that's up to you. And most of the time, we only need a current firmware version. And then when we have updated these twin collections, and actually one of the cool things you may spot there, because I have two twin collections. The first one is the properties, and the properties is actually can have sub collection. So we have a sample here. Yeah. So this is a one of the device twin where you can see the tags I told you about earlier and the properties. And as you can see, you can nest properties with other properties. So you can have quite complex there, which is quite interesting. You can actually only update part of the all the devices. Okay. So yeah, when you have created your updating twin collection, you need to call the client update reported properties async to actually push the update. So I will go ahead and that. Done. So now my device has updated its device twin in the cloud side with the latest firmware version, and then I will need to attach fallback. So when the IoT Hub client on the device receive a new device twin update application, you can actually execute your own code and launch firmware update. Okay, so we'll go ahead and run that code. So you have an idea of what it's done there. This callback actually receives new twin collection with only the desired properties and only the part of the desired properties that have been. Okay, so you're not receiving all the desired properties, updated properties. And what we will do there is we'll only check if the desired properties contain a property called firmware, and if actually there is a property, then we try to part that as a twin collection and actually launch method to do the there. If you look at the update firmware code, that's very silly. It's just a sample. It's just an actually just update the firmware in the console, have some delays downloading and then an updating and a binary integrity. That's it. So all the steps are correct. You need to basically download the binary of the new firmware. You need to check the integrity, buy it, and you need to reboot. But as you can see, everything is taken there. The process is correct, but you will need to update the code. So when we execute this on the terminal, and sorry, I have a lot of garbage because I have the debugger activated, but basically what you can see is that the device is booted and the current firmware 1.0. And that's it. And we will leave this program running while we are doing things in the Azure portal to actually simulate an update. So I will go on 5, which is test firmware update on a single device. I've done this through the F5. We saw this in the output, and then now I will go on the Azure portal. And I'm logged in my Azure portal. So we can go ahead. We can go ahead, see the hub. I've created JulyOT. I will play my actual. So how do we actually push a new updates to specific device? So to do this, you will go ahead there on the under the automatic device management section, and you can click on IoT device configuration, and we will actually create new device configuration. I will pick a name, that one, firmware update 110. And then I go on twin settings, and that's one of the cool things, because actually you can use this device configuration to change other things. So as I said, if you are using the device twin, handle the configuration of your IoT device, like for example, trigger an alert when the temperature is 10 degrees Celsius, and you actually want to change this 10 degrees Celsius remotely. Simply have that temperature alert threshold as a device twin. Use that device twin to actually push configuration. But for now, we want to update the firmware, so actually properties desired firmware twin property, and the value of the property will actually contains a few different. we will need a version number. We will need a URI, so the device will actually download the binary from it, and also a check value checksum. Okay. So again, all this is fake. The only thing there is more version, and we want to sure that the IoT simulated device will output this new. It's just because I'm size. So we will go ahead and click next. And one of the other cool things we can ask the automatic device management system to actually collect metrics while applying this device coverage. So that's one of the cool things, because you're not only saying to Azure, hey, please update all these type of devices for me, but also collect some specifics, so you can be sure that the correct number of devices will. So we will create a new metric next, more updated, and as you can see, there is a small SQL-like query language, so you can actually query all the metadata from all the devices. So there I'm selecting device ID for devices where reported firmware current version is updated my new. Okay. And then we need to update the priority condition. This is useful when you're deploying a solution to a huge number or different devices, and maybe a specific devices will be the target of several configuration updates. When it's a case, the system will need to prioritize all these updates, and that's where you can update with a simple number, higher value with higher priority. You can actually rank the updates to be done first. And the last but not least part for this is, as I said before, I want to test the firmware update on a single device. So I need to form the Azure IoT Hub that actually I want only one device update, and I can do this there by simply device ID, or and I called it JulyOT. So that target condition is interesting because again you can use tags as well, so you can group a device update by location, by customer, by environment, by a lot of different. So it's very simple, but also very. So I will go to the last step, and as you can see, I've actually JSON file that is describing my update, and I've done this through the Azure portal. But if you are using the Azure Resource Manager SDK, you can actually automate this thing with code. You may want to create small web interface, for example, for actually managing your firmware update without having to go on the Azure portal each time you want to. That's something you can do if you have. So I will go ahead and create this new device string configuration. And now I only need to sit back, relax, and see the magic happen. So for this, I will go there, play my code, and if I'm lucky, I should see in it that my simulator there will actually play. If I didn't make any mistake, oh no, I made a mistake. I made a mistake. I will try to clone it. Twin settings, metric system, and then I made a mistake. JulyOT let's not do the mistake twice. By IoT. By IoT. What one I will. So what we should see in this output, basically the simulator taking this new update and applying this update. So we will see if I have more luck. So it takes few seconds actually, which should see how it's done. If it's not working in a few seconds, I will go ahead and show you how to do it in a more large scale way, and we will come back to that. So what should be done there is if we go on the IoT devices pane. Oh, we devices. Oh, sorry. I'm definitely not awake today. The name of my device is actually simulated one. Sorry for vision there. So go ahead and clone. Good one. That device. JulyOT is actually the name of my IoT hub, and that's silly. So yeah, that's working. So as you can see, the IoT simulator picked up the updates and actually is downloading the new firmware, verifying it. And if I go to IoT devices, I will try to do it quick and actually go over and device twin. You can see that I have here reported firmware version of 1.1.1 with the status applying. So I know that my firmware has been downloaded and is pending apply. And then my device has been booted and the new current firmware is updated. I can go and refresh that. And we should see now that there is no pending firmware version and my current firmware. So again, the automatic device management, the only thing these things does is actually enabling you to change a huge number of device to devices and also getting statistics. So if I go back to IoT device twin management, you should see now that one has been targeted and one has been applied, and I have also my custom metrics where I've created, and if I view it, I can see that my simulated one device has been indeed created. So you can track all of these things directly from this configuration. So this is how we can use IoT Hub to actually update one device, but where the magic is actually how can you do it for huge number of scale. So before jumping on that, there is some challenges and risks, of course, configuring a large group of devices. Because what you will do when you deploy a new firmware is actually because firmware is correct and deploy it to all your devices, you may not be able in the future to update against the device. As I said before, on a lot of IoT devices, you have very simple OS, or maybe not OS at all. And as you've seen within your code, is my program is not running my code, I will not be able to actually run this thing because it's my own program that actually does. So if something is bad happening within your firmware, you will be basically doomed. You will not be able to. So you need to be very careful when you're doing this, and you mostly need the where you are pushing your we call it limiting the or controlling the blast. So maybe the first thing when you have a new firmware, maybe the first thing you only deploy it to small group of devices or only your smallest customers, or maybe you know that some customers are closer to you, so you'll be able to actually move and go on site to fix things. So you will be first deploying these customer dates before deploying to other overseas customers. So it's up to you to decide your deployment matrix to actually limit your blast service, limit the number of device updates, and when you have, for example, firmware update version 2, when you have updated for customers, then you can expand for the same more, and that's definitely something you can do basically with the device twin tags and Azure IoT Hub automatically. So that's exactly the purpose of the next two exercises, and I will leave you as a home exercise to actually go ahead and do it, but I will go through module quickly. Few information, few interesting on your own. So the first thing we want to simulate there is to have more than one devices. I think 10 devices. It's just for simulation. You can write a script to 100 of devices, and we will prepare 2 firmware update campaigns for 2 customers. That is, so actually we will use device twin property tag, sorry, a device twin tag to identify which devices are belonging to Lewis customer and which device. So for creating all these new device identities, we will actually create a bash script. And if you don't know it, if when you're within the Azure Cloud Shell, you can simply type code space and name of a file, and you can actually edit this file right within. And then you just have to copy paste this bash script and to replace there by the name of your IoT app. So in my case, I will not make the mistake twice. JulyOT. And then you need to go the upper right save, so you will be able to execute. So there, this script will actually do different things. It will actually create a device identity, but also update the device twin. So as you can see, I'm adding customer tag. And then the other interesting things that is done from the CLI on the second part is you will not go onto the Azure portal to actually create a device configuration update, but you will actually craft a JSON file as I show you at the end of the wizard, and use that file directly from the command. So as I said before, if you want to automate firmware updates without having to go on the Azure portal, you can definitely create a program for it, a web app, for example, or also you can print a bunch of bash scripts, and you can actually use them within your CDCI pipeline if that's totally doable. So you have actually different JSON files to create. The first one is device twin property update, and 2 other ones are about getting the metrics of your, and then you can actually use the Azure AZ IoT Hub configure command to push fast update to IoT Hub and then devices. And you can also use the Azure IoT Hub CLI extension to actually display the metrics from within without having to go on the portal to how many and which devices have been updated. Okay. So that's basically what you will do in this last step of Microsoft. It seems that I don't have any following questions. I hope you enjoyed my module despite the small audio issue at the stream. Again, if you have any questions, do not hesitate to ping me to just add a comment onto on the video. Next week, we will do another interesting module around time series. So what we saw up to now is how to actually code an IoT device, send data to IoT Hub and to your applications. We've also seen today how you can code configuration and updates from the cloud to your devices. But one of the next steps when you have actually built this part of the IoT solution to get some insights and some data from your IoT device. And in next week video live stream, we will actually see how to use time series insights to very quickly get data from IoT devices without having to code anything again or without having database. IoT time series insights is the stream will start at the same time, which is 5 p.m. Paris time, 8 a.m. Seattle time. And meanwhile, if you have any question about IoT, don't hesitate to ping me on Twitter or on LinkedIn, and also to follow JulyOT by all the news from my colleagues, because I'm not the only one from Microsoft. A lot of IoT stuff and tutorials and video. We are doing a bunch of things. So please check out the other content you may have around IoT on JulyOT.com. Thanks for watching and see you next week. Bye.